Hi students, in this video, sir would like to explain a question from the chapter indices, surds and logarithms. Okay, to move on to this chapter, I need to tell you a few things. Okay, for to master this question, so you must have a basic from the chapter circle. Okay, you must have the basic from the chapter circle. Okay, now, along the explanation, I will give you the idea. Actually, this idea is actually not from this chapter. It's actually from the chapter circle. Okay. Okay, let us move on to the question class. Let us move on. Okay, as you see here, this is the diagram provided for us with the three circles, and the circles are touching each other and with one common tangent. So the meaning of the common tangent is the tangent which touch all the three circles at once. Understand? So that is the meaning of common tangent. Okay, let me read the question for you, class. Okay, diagram above shows a three circle. The diagram above shows a three circle. Circle A has a radius of 2 centimeter and the circle B have the radius of 1 centimeter. PQ is the common tangent. PQ is the common tangent as I told you, right? Can you see a line PQ there with the common tangent? They are common tangent to the three circle. And all the circles are touch one another. Okay, got it, huh? Okay, we move on to next. Okay, find the radius of the smallest circle in form of surd. That means the answer that you're going to provide, the final answer that you're going to provide, right, should be in form of surd. In form of surd. You cannot give the answer in the decimals. Understand? Clear, right? Okay, let us move on to the chapter class. Sorry, let us move on to the question. Okay, now I'm going to explain one by one for you. So try to understand. Now, if you have a problem, since this is a video, right, you can, what you call, rewind and see again which part you have a problem. That is the beauty of video. Video is something that we already recorded, right? So just you can go again and watch again and then try to get the idea. Okay, let me start class. Okay, the first thing here is I'm going to draw a radius. This is your radius for the big circle. Okay, as I told you, right, you must have the idea from the chapter circle. Okay, radius and tangent. Radius and tangent. Class, this is the tangent and this is the radius. And radius and tangent will form a 90 degree. That is the concept given us in the chapter circle. Okay, radius and the tangent will form a 90 degree. So again, I'm going to draw another radius on the circle B. Okay, again, a radius and also tangent meet. So the radius and tangent will form another 90 degree here. Okay, after that, what I'm going to do is I'm going to connect them with this line AB. Okay, what I can see here is a trapezium. We form a trapezium. We form a trapezium. Always remember, if you have a trapezium with, like, for example, I just give you one example. Okay, this is a trapezium. Okay, just a simple trapezium with the 90 degree over here. You can cut the trapezium, make them, what is this? A rectangle and with one right angle triangle. So you can do that. Okay. So that is what we can see there. Can you see the trapezium with the 290 degree here? Okay. So what I'm going to do here, I'm going to draw a line. Sorry, first thing before that, this is make myself easier. So I'm going to label all these points with one alphabet, easy for me to refer back later. So this one I'm going to label them as a C, and this one I'm going to label as a D, and this one I'm going to label as a E. So easy for me to refer the side easily, okay, so that you can understand. Okay, now once I know this is a trapezium, I'm going to divide this trapezium into two, what you call, geometry. This one is a rectangle, another one is a triangle. Okay, this one is going to be 90 degree. Understand? Okay, since this is a rectangle, right? Since this is a rectangle, so whatever value here going to be same here, and whatever value over this side will be the same over here. Understood, class? So that means this one should be equals to this side, and this one should be equal. Okay, got it, huh? Okay, so now they already give us the information that this small circle, the radius of the small circle is 1. If this is 1, automatically this one also going to be 1. Got it? That's the first understanding. And after that, the radius of the big circle right here, the radius of the big circle is 2. Okay, we already have the 1 here, the balance 1 will be on top here. Understand? So now I already have all this indication ready for you. And then after that, this length is 2 centimeter, right? Because radius is 2 centimeter and this particular radius is 1. The total of both going to be the length of AB. So now the length of AB going to be 3. So maybe you're asking me, so what we are doing now? Actually, we are planning to find the length of EC. This one, the length of EC. Because this length and the bottom one should be equal, right? So actually, we are trying to find the length of EC. So what I'm going to do for you, I'm going to take out this triangle out for you. So that easy for you to see. Where this is 3, and this is 1, and this is the right angle triangle, right? Okay, so I'm going to label this one as a CE. Got it? Easy for us, right? Okay, same, right? Because CE and this one is going to be same. So I'm just going to label as a CE. So I'm going to get the length of CE now. Okay, CE going to be, I'm going to use the Pythagoras theorem class, square root 3 square minus 1 square. Okay, if you use the calculator, some of the calculator will show decimal, so better don't use calculator. Okay, so you can just leave it as a surd form. It's a, okay, this is a 9. 9 minus 1 is going to be 8. So the answer going to be square root of 8. Got it? So we already managed to get the value of the length of the EC here. We already get the length of EC. That is a square root of 8. Understand? So let us move on to the next slide. Okay. So my next slide, so what I'm going to do here, I'm going to touch the small circle, this one. So I'm going to draw a radius here. Okay. Okay, this radius I'm going to indicate as R. I'm going to indicate as R. So that is the R that we're going to find later. Okay, because the question asked to get the radius of the smallest circle, right? So we're going to find the R here later. Okay, so that's why I put R there. So can you see a connection point here between these two circles here? So what I'm going to do, from A, I'm going to draw a line like this. Okay, sorry class. The radius and the tangent will form a 90 degrees. So don't forget about that. Okay, then we're going to draw a straight line over here. And after that, what I'm going to do again, this is a trapezium, right? Again, this is a trapezium. We're going to use the same idea. We're going to divide this trapezium into two geometry. The one is a rectangular, another one is a triangle. So I'm going to draw a line over here. Understand? I'm going to draw a line over here. Okay, done, huh? Okay, so I try to label for you first. Okay, class, you know, right? This is R. R means automatically this is also R. Okay, the radius is the 2 centimeter. Radius is 2 centimeter, right? Okay, and this particular part is going to be 2 minus R. 2 minus R. Got it? Okay, and this radius is 2, and this small part is R. So the total length of this triangle going to be R plus 2 or 2 plus R lah. R plus 2. Got it? Done. So what I'm going to do here, this triangle, right? For this triangle, I'm going to take out this triangle for you out here. So that easy for you to understand. Okay, where I'm going to label all this again, 2 minus R and R plus 2. Okay, so going to find this ED now. The length of ED. Okay, in terms of R. In terms of R. Okay, let us start. ED, sorry. ED. ED, right? Okay. So the length of ED is, or DE lah, whatever, ED or DE, is going to be square root, the whole thing is a square root. Don't forget to square root all thing again. Square root. Okay, the hypotenuse need to minus with this, right? Okay, got it, slowly. So R plus 2 square minus 2 minus R square. So let us expand this whole thing again. We need to expand class. It's going to be R square plus 4R plus 4. Class, careful here. I want to expand. At the same time, there's a negative outside here. So I'm going to reverse all my sign. Okay, this is going to be 4. So because when you square, 2 square is going to be 4, it's going to be negative 4. Because outside got negative. So after that, we're going to multiply all this. You're going to get negative 4R. Outside going to be plus 4R. And R square going to be negative R square. So we try to simplify. R square minus R square is 0. 4R, not this one, sorry. 4 minus 4 is 0. So we're going to end up with this. sorry, we're going to end up with 8r. Got it? Okay, done. We already done for the first triangle. So this triangle. So now we're going to take the second triangle. This is a red triangle. I already highlight for you. Where the same idea class. This is r. Okay, the total radius is 1, right? So this one going to be 1 minus r. Okay, this one is still, remember, this is 1, and this is r. So when the total is going to be r plus 1. Okay, so I'm going to take out the triangle for you out. I'm going to label r plus 1 and 1 minus r. Okay, this is a DC now. So again, I'm going to find the value of DC now. Okay, we're going to put square root. Again, the same idea. We're going to use a Pythagoras theorem. Okay, that is this one minus with this, right? So that is r plus 1 square minus 1 minus r square. Okay, so let us expand this whole thing again. Everything the same idea class. Idea is actually the same. So it's going to be r square, r square plus 2r plus 1. But this one, when you expand, make sure reverse the sign because of the negative outside there. Okay, the same thing I told you, minus 1 plus 2r minus r square. So r square gone. 1 plus 1 minus 1 also gone. So end up with 4r. End up with 4r. Okay, you know what is my idea now? Okay, what we know that we already managed to get this length. So that is the DE, that is square root of 8r. And we already have this length now. That is a square root of 4r. Right? And also remember, we already have this. We already have this. The total of the EC is a square root of 8, right? Is a square root of 8. So that means the total of both is going to be square root of 8. That is our idea now. We're going to use up. Once you solve this, that means you already managed to get the what is the r. Okay, got it? So I think I need to move on to the next slide. Easy. Okay, let me do here. Square root of 8r plus square root of 4r equals to square root of 8. Okay, so to remove this square, all these square root things, right? We need to square both sides. So what are you going to do? You're going to square both sides. Listen. Okay, you're going to square both sides. Okay, done. So let us move on to square the whole thing. Class, I won't skip anything because this is a video, right? I won't skip anything. I will give you one by one. So try to understand slowly. So when you square this, it's going to be this. Square, right? Plus. Okay, square root of square root and square for this particular thing is square root will be gone. We just leave it 8 first. Okay, this one class, same idea. When you square this whole thing, square with the square root gone, you'll get 8r. Okay, this one class, careful here. I'm going to leave it the 2 outside. Okay, these 2 square root can be combined. Okay, so combine means the internal value can be multiplied. So that means I can multiply them into like this. 32r square. Because 8 times 4 is 32, r times r is r square. I already combined them as 1. Okay, this one square root and square going to be 4r equals to 8. So 4, okay, right? Okay, now it's going to be 12r. You know why it's 12r? Because 8 and the 4 can be plus. They are like terms, we can plus, going to be 12r. Okay, plus 2. Class, inside here, I'm going to simplify them for you. Okay, listen how to simplify. Listen. Okay, I'm going to take 16r square times 2. So try to look at this one carefully. Because 16, why I take out 16 separately for you? Because 16 is a perfect square number, right? So we can square root the 16 easily, right? So because 32 is a 16 times 2, right? 32 is a 16 times 2. Okay, now listen. Okay, so these particular things, we already have the square root. What is the square root of 16r square? So 16r square going to be 4r. Okay, this 2 no square root. So since no square root for 2, no perfect value for 2, right? So still remain inside the square root as a square root of 2. Understand, huh? Because actually we can divide them, we can cut the square root into 2. One is going to be 16r square, square root of 16r square. Another one is a square root of 2. So the square root of 2 is still inside the square root because no perfect value, right, for them. Okay. Okay, now still can continue 12r square, 12r plus. So this one going to be 8r with the square root of 2 equals to 8. Got it? Okay, so I'm going to divide all by 4 because I can see everything is a multiple of 4. I'm going to divide all by 4. It's going to be 3r plus 2r, the square root of 2, and equals to 2. I divide all by 2, divide by 4. All divide by 4, divide by 4, and divide by 4. Understood? Huh? Divide by 4. All must be divided by 4. So now the question asks for r, right? So I'm going to factorize the r for you. You have 3. So I'm going to continue here, class. Sorry. Okay, so the final answer is going to be r equals to 2 over. Okay, this one is, this whole bracket is times. So when you bring the times over that side, it's going to be divide. 3 plus 2 square root of 2. And this is your final answer, class. Hope that you can understand this video. Try to watch few times so that you can get a clear picture. Okay, that is my advice for you. Okay, class, thank you. Have a nice day.